Okay, hello and welcome to another paper. This is October, November 25, and the variant is 4.3. Let's start solving. I think the threshold for this was actually pretty low. It was 36. Okay, so 36 for an A. I think that was the threshold. Let me just quickly Google that as well. Yep, 36 for an A. I think that makes it a very difficult exam. Let's start solving. Let's see what this paper holds for us. I am going to quickly open up the marking scheme so that I can verify my answers on the go. Okay, question number one is from Kinematics. It says the diagram shows the velocity time graph of the journey. And what I have to do is the athlete runs in a straight line. Okay, the athlete runs in a straight line from point A to point B, runs back to point A and finishes at point B. Uh, the graph consists of four straight line segments. Okay, so its starting point is point A. Okay, so remember that this is a VT graph. Okay, so this or actually the velocity equals to zero indicates a change in direction. Okay, so we'll see what this athlete is doing. Okay, find the deceleration of the athlete 7 seconds after leaving A. So I think that is this point. He's leaving A at the start, okay, at time zero. He's at A. So I'm asking you to find the deceleration at this point. I think I have all the coordinates. I can say that this point is 5 comma 8 and this is 15 comma minus 8. So I can just find the deceleration and say that the gradient is minus 8 over 15 minus 5. So I am getting minus 1.6. So deceleration has to be 1.6 meter per second square. Okay, find the total distance traveled by the athlete. So the total distance has to be everything that you see in the curve. You don't have to subtract any distances. You just have to find the area of three triangles. I see three triangles. So the first triangle is half base into height plus half. What's the base now? Again, it's 10. And the height is also 8. Okay. And that's what's happening again as well. Okay. Because it's just running back and forth. Okay. So it's just 3 over 2, 10 into 8. And that's for 120 meters. Okay. That's easy, I think. Okay, nothing very complicated about this. The only complication was back to point A. What's happening is that he decelerated. Okay, and this was probably point B. He started running back. He ran back to point A and then to point B again. If it had asked in the question, I would have done that. Okay, the engine of a motorcycle can generate a maximum power of 105. The mass of the motorcycle rider is 400 grams. The total resistance to the motion is CV newtons, where V is this. The motorcyclist travels along a straight horizontal road under maximum engine power. When the motorcyclist's speed is 35, his acceleration is zero point 0.5. So show that C equals to 30. Okay, let me draw this. So maximum power is 105. He's always traveling at maximum power, so that his driving force is then 105 kilowatts, right? So 105,000 over 35. Okay. What is the resistance? The resistance to the motion is CV newtons. V is then 35. Okay. MA, what is mass and acceleration? So F equals to M is what I've applied. My driving force is 105,000 divided by 35. So that's 3,000 minus 35C equals to 200. minus 200 divided by 35. So C is coming out as 80. That is what I had to prove. The motorcyclist now travels up a straight hill under a maximum engine power. The hill makes an angle of sine theta equals to 3 over 20. Find the steady speed. Steady speed is when acceleration is 0. So V is V. So I can say now that there's gravity involved. That's the only thing that seems to have changed. So that's 4,000 sine theta. So I'm going to say driving force is maximum engine power is 105,000. So 105,000 divided by V. That's what's driving. Okay, power equals to FV basically. So 105,000 over V. What is the resistance? The resistance is CV. So 80 times V again minus 4,000 sine theta. Sine theta is 3 over 20 equals to MA. So 400 into 0. Okay, why? Because steady speed means acceleration is 0. So 105,000 over V minus 80V. Let's just simplify all of this. So minus 600. Okay, equals to 0. I can move this to the other side, both of them, and I can cross multiply and end up with a quadratic equation. I don't know this space. I'll have to create some space. So 80V square plus 600V minus 105,000 equals to 0. So minus B plus minus B square minus 4AC over 2A. Okay, the questions seem easy so far. Threshold is pretty low, which tells me that this might have been a difficult exam, but let's see. So I'm getting an answer that says 32.7. Okay. And then there's a minus 40.2. Obviously, that gets discarded. So meter per second. Okay, a block of mass 4 kg is pulled along a rough horizontal road. Quickly on to question number 3. Rough horizontal road by a constant force of 25 newtons, making an angle of 36 degrees above the horizontal. Okay, so this is going to be 25 cos 36 and 25 sine 36. The block moves in a straight line passing 2 points A and B on the road. AB is 120 meters, so the distance covered is this. The coefficient of friction between the block and the road is this. Okay, 40 or 0.4 R. Find the work done against the friction in moving the block from A to B. So as long as I can find out the friction quickly, that should solve the problem. So R plus 25 sine 36. Up forces equals to down forces. So R is a number, 40 minus 25 sine 36. Okay, up equals to down, 25.305. Okay, so 25.305, that's R. So I can say that work done against the friction or work done by the friction is basically 0.4 into 25.305 into 120, because that's the distance moved. 1214.657,697. Okay, so three significant figures: 1210 joules. Okay, 1210 joules. Let's see. Yeah, that is the correct answer. Okay, the speed of the block is at a 7 using energy method. So energy method simply means that work done by driving force equals to change in K plus change in P plus work done by resistance. So my work done by resistance should be 1214.66, let's say. Okay, there's no change in P, of course. Half M V is what I'm trying to find, and the starting speed is 7. The starting speed is 7. Okay, what's work done by driving force? The horizontal force was 25 cos 36. So 25 cos 36 into 120. 120 was the distance, right? So 120. So 25 cos 36 to 120 minus 1214.6. That gives me 121239. So 2v square minus 7 square. Divide by 2 plus 49. And then root of answer. So that gives me v as 25.6 meter per second. Let's check if that's the correct answer. Yes, the correct answer. As long as you write the equation, write the components, you should be fine. Let's quickly move on to question number 4. A particle P moves in a straight line. At time t seconds after passing through point O on the line, the displacement of P from O is 7 meters, where S is this. Find the value of S when P has its minimum velocity and find also the speed of P at this. Okay, so I'm given a displacement time equation. Okay, find the value of S when P has its minimum velocity and also find the speed of P at this instant. Minimum velocity. Okay, that is a 6-mark question. So it's going to take me some while. First, I'm going to differentiate it and say that this becomes a 0.03 t squared minus 0.6 t minus 2.07. But I'm not trying to minimize s, so I won't put v equals to 0. I don't want the velocity as 0. I want the minimum velocity, which means that I'm going to differentiate again and say that this is then 0. So at the minimum velocity or at the maximum velocity, acceleration is 0. So 0.06 t. So t is coming out as 10, I think. So at 10, what is the velocity? Minus 5.07, is that correct? Yeah, minus 5.07. Yeah, that is the correct velocity. Find the value of s when p has this, find also the speed of p at this instant. So s is then 0.01 10 cubed minus 0.3 10 square minus 2.07 10. So 0.01 into 1000 minus 0.3 into 100 minus 20.7. Okay, so the displacement basically minus 40.7 meter per second. Okay, those are the two final answers that I have. I think that was an easy question. Find the acceleration of P at the instant when the direction of motion of P changes. When does the direction of motion change? When V equals to 0. So I'm going to solve this equation. 0 equals to 0.03 t square minus 0.6 t minus 2.07. So use the quadratic formula. Don't do it directly. You are not going to get marks if you don't show me a quadratic formula in this question. I hope I've written down the numbers correctly. I just want to take a quick check. Yeah. Point 0.03 minus 0.6 minus 2. So 23 and minus 3. Of course, minus 3 can't be a value for time. So discard and then consider this. I'm trying to find the acceleration. So it's going to be 0.06 into 23 minus 0.6. 0.78 meter per second square. Yes, that is the correct answer for this again. We're quickly on to question number 5. This is a police question. It says particle A and B is this are attached to the lines. The string passes over a smooth fixed pulley, and the particle hangs below the pulley. Both particles are initially held at rest. Above the horizontal ground, particle is projected vertically downwards with the speed of. This is the first time that is happening. That you're pushing it down. Well, u equals to 1.2. Okay, so this is 2, this is p. This is 60, 20, sorry, 20 nt and 60 nt. Find the tension in the string and the magnitude of the acceleration of the particle. Okay, so in this case, the motion is basically in reverse. So at A, what's happening is that I'm moving down 20 minus t equals to 2a. At B, it's t minus 60 equals to 6a. Okay, I think acceleration was going to come out as negative because the system has to slow down. Okay, why does it have to slow down? Because we're moving in the opposite direction. So minus 40 equals to A is minus 5. So it is slowing down. Then what's the tension? T comes out as 30. So A is minus 5 meter per second square and T is 30 newtons. I think those are the correct answers. Yes, those are the correct answers. It says in the subsequent motion, A does not. Okay, so let's think about this question. In the subsequent motion, A does not hit the ground. So A was pushed down, so B was pushed up, and neither the particle reaches the pulley when B hits the ground. So it's going to reverse after that, right? Because A can't keep it sustained, it is decelerating. What's happening with B? It started off at 1.2. It was accelerating at minus 5. It was above a height of 3.2 and then it went and hit the ground, which means that its final displacement was minus 3.2. I can say that. What am I asking you? I'm asking you when is final displacement. So S equals to UT plus half AT squared because it was 3.2 meters above the ground. Minus 3.2 UT half AT squared. I don't know why it's a 2-mark question. It's a lot of thought into it. So 2.5 t square minus 1.2 t minus b plus minus b square minus 4ac. Okay, so t is coming out as 1.3965 or t is coming out as minus 0.9165. So the correct answer should be t is 1.4. Okay. Okay, so let's break up A's journey now, because I want to find the distance between the highest and lowest points that A reaches. So what's going to happen is A is going like that, and then it's going up like that. Okay. Uh, this journey started off here at 1.2. It had an acceleration of minus 5. I want to find out the lowest point, and I know that V is going to be 0. So V square equals to U square plus 2AS. Okay, V square is 0 square, 1.2 squared plus 2 times minus 5 times. S, so S comes out as 0.144. Okay, that is what I have. So this minimum point is 0.144. What is happening at that point? The motion is reversing. So I have the entire opposite equations. What I am going to do is I'm going to say that now the equations are reversed. What is driving A? T minus 20 equals to 2A. And then B is going down. So 60 minus 10, T equals to 6A. So T equals to A equals to 5. Okay. Now what I am saying is that particle is starting off again. It has an acceleration of 5. I should find out how high does it go at this point. Okay, I know how high is it's going to go because B has to hit the ground. So this is going to be 3.2 and this is going to be 1.144. So S is going to be a total of 3.344, I think. And then V has to hit, I don't know what V has to hit. Okay, that is what I really need to find. Okay, so I'm going to say V square equals to U square plus 2AS. So V square, 2A, and S. Let's see if I am able to find out. So I'm getting 33.44. That is the speed when B is hitting the ground. That is the speed when B is hitting the ground, 33.44. After this, what happens is once the motion breaks, A's equation is going to say that it was previously this. Because B has hit the ground, the system is now broken. What is A going to do is A is now going to move with A is going to move with gravity. Okay, so it has a starting speed of root of 3.33.344, 33.44, sorry, 33.44. Okay, so it has a starting speed of 33.44, going to reach a point that is its highest point. Its acceleration is going to be 10. Find out this. So V square, U square, 2AS. So 33.44 divided by 20. So this is giving me 1.672. Okay, so let's have the numbers first. What was happening? A was first moving down like that, then it went up like that, and then it went further up. Let's make that smaller. Okay, so it went a distance of 0.144. This distance was 3.2, where it returned to its initial position and then B hit the ground. Then it went further up. How much did it go further up? 1.672. So what is the distance between the highest point and the lowest point? It's all of these three added together. So I'm getting 5.016. I think that was a tough question and you should practice it. Okay, moving on to question number 6. There should be a question number 7 for this. I think there should be an 8 as well. No, 6 and 7. Last two questions, let's do them quickly. Particle P of mass m kgs and particle Q of mass 2 kgs are free to move on a horizontal plane. P and Q are moving directly towards each other. So P and Q, very similar to this. Okay. Free to move on a P and Q move directly towards each other with the speed of u and minus 3u. P and Q collide and the direction of motion of each particle is reversed by the collision. Immediately after the collision, speed of P is minus u over 3. Find in terms of m and u the expression for the velocity of Q after the collision and ensure that m is greater than 4.5. So before equals to after collision, momentum question. Momentum is mass into velocity plus mass into velocity, and then mass into minus u over 3, final velocities, and 2v. So mu minus 6u equals to minus mu over 3 plus 2. Okay, so mu plus mu over 3 minus 6u equals to 2v. So 4 mu over 3 minus 6u equals to 2v. So v is equals to 2 mu over 3 minus 3u. So yeah, okay, I'm dividing both things by 3. Okay, so what do I know next? I know that this velocity was in this direction, which means that it was positive. So 2 mu over 3 is minus 3u is greater than 0. So 2 mu over 3 is greater than 3u. 2m is greater than 9. And m is greater than 4.5. Yeah, okay, I have the correct answers. Q subsequently hits a vertical wall which is perpendicular to the direct motion of Q. So Q is hitting the wall. Where is Q? Q is this. Find the velocity of Q. So Q's velocity was 2mu minus 3. The speed of Q after the impact with the wall is a quarter of its speed before the impact with the wall. There are no further collisions between P and Q. Given that m is an integer, determine the largest possible value of m. Okay, so that is interesting. So Q had a speed with the wall. Now collision with the wall. Q had a speed of 2mu over 3 minus 3u. Now it's saying that after the impact of the wall is a quarter of its speed before the impact of the wall. Okay, so after impact, uh, what is happening is I know that V was moving towards that direction, so I'm going to say that after the impact, the direction is going to reverse. So it's going to be minus 1 over 4 2mu is a quarter of its speed. Minus 3u. Okay. So this tells me that there are no further collisions between P and Q. What was the speed of P? It was minus u over 3. So I'm going to say that minus 1 over 4. Q is going, P is going to be faster. Okay. So P is faster than Q. Okay. Since they're both negative, what I'm going to say is that minus u over 3 is going to be less than minus 1 over 4 2mu over 3 minus 3. U is common to all of them. I'm going to get rid of that and use a positive number. So I should also do that. Okay. If I cancel out these two negatives, I'll have to flip the sign. So I'm going to do that. 1 over 3, 1 over 4, 2m over 3 minus 3. What is it asking you? Determine the largest possible value of m. Okay. So 4 over 3 minus 3. So 4 over 3 plus 3. 4 over 3 plus 3 is 9 plus 4 is 13 over 3. Is greater than 2m over 3. So m has to be less than 6.5. Okay. Less than or equals to. This has to be equals to as well. And as I recall, it should be equals to y because even if they're moving in the same speed, they're not going to collide. So m is less than or equals to 6.5. So I think that the greatest possible value of m should be 6.5. Okay. There's a question like that in my lecture as well, and people ask me why I keep doing that question. So it came up in November 25. So you should know. Okay, let's look at question number 7. Question number 7 says a particle P of mass 6 kg is on a rough inclined plane at an angle of theta. Horizontal force of magnitude 12 newtons acts on P as shown in the diagram. The line of action of this horizontal force lies in a vertical plane which contains the line of greatest slope. Lots of information there. The coefficient of friction between plane and the mu is this. P is in equilibrium and on the point of sliding down the plane. So mu into r. Show that mu equals to 5 tan theta minus tan 1 over 5 plus. I don't know where tan theta is coming from, but let's try to solve. Twelve cos theta and 12 sin. So up equals to down and left equals to right. Okay. Up and down r. And down is 60 cos theta plus 12 sin theta. Okay, what's left? 60 sin theta. What's right? mu into r plus 12 cos theta. Okay, the only thing that I can think of doing is I can replace r with all of that. So 60 sine theta equals to 60 mu cos theta plus 12 mu sine theta plus 12 cos theta. We have the equations. Let's solve. I the thing that I've done is I've replaced r. So what I can think of doing is keep mu terms on one side and other terms on the other side. Okay. So I can factor out a mu from here. So 60 sine theta minus 12 cos theta over 60 cos theta plus 12 sine theta. Okay, how do you convert everything to tan theta? Okay, I need a tan theta. I know the coefficients are a little messed up, but we can do that again. We can factor out something later on. The idea comes from some AS identities where I taught you that you need to divide everything by cos theta in order to make tan theta. So I've done that in the numerator and I've done that in the denominator as well. Let's see if I have the required answer. What I am getting is I'm getting 60 tan theta minus 12. Okay, this cancels out. And then 60, this is canceling out, plus 12 tan theta. I think I can factor out the 12s and get 5 tan theta minus 1 over 5 plus tan theta. So 12 and 12 cancel out. That is the final answer. Never seen a question like that, but it's there. Hence, find the set of possible values of theta. Okay, hence, find the set of possible values of theta. Let's think about that. Uh, One thing that you should know about mu is that mu is greater than 0 because it has to be in the positive direction, in that direction. So mu is greater than 0. So 5 tan theta minus 1, 5 plus tan theta is greater than 0. I think theta has to be in the first quadrant, so tan theta is also positive. So what I can do is I can get this to cross multiply. So tan theta is greater than 1 over 5. Inverse, tan inverse of 1 over 5. Giving me as 11.3. So theta is greater than 11.3, but theta is also less than 90. That is what I should state. Why? Because I have to keep it positive only. In the second quadrant, it becomes negative. So that is the final answer. Okay, that's it for this exam. Thank you for watching.